Okay, question 1. So we've got 5 to the power of 4 squared. So when you're squaring something, all you're doing is timesing it by itself. So we can expand this, so you get 5 to the power of 4 times 5 to the power of 4, and when you're multiplying indices like this, you're just adding them. So we're going to get 5 to the power of 8, which is here. Okay, question 2. Circle the volume in centimeters cubed of a cylinder with radius 5 and height 8. So we know the formula for a cylinder, which is going to be pi times the radius squared times the height. And we know the radius, which is 5, and we know the height, which is 8, so we're just going to substitute these numbers in. So we can get pi times by radius squared, which is 5 squared, times 8, which is going to be pi times 25 times 8 equals 200 pi, which we've got here. Okay, question 3, simplify 16a squared divided by a plus 3a times 2. So let's put these in brackets so we can separate it out a bit. And then we're going to rewrite it to make it nicer. So 16a squared over a plus 3a times 2. Okay, what can we do on this side? So 16a squared over a. This means 2 of the a's will cancel out. So we're going to get 16a plus 3 times 2 gives you 6a equals 22a, which is this one. Okay, circle the value of cos 30 degrees. Okay, there's no easy way to do this. You've just got to memorize this. So the value of cos 30 degrees is root 3 over 2. Okay, question 5. Work out 8.5 divided by 2 2/3. Give your answer as a mixed number. Okay, this is 4 marks, so there's going to be quite a lot of work for this one. So the way I'm going to do it is I'm going to turn these into improper fractions. So first we're going to do 8 1/2. What is that as an improper fraction? So we're going to turn it into 17 over 2 divided by, and now we need to turn the second one into an improper fraction, so that's going to be 8 over 3. And how can we do a division easier? Well, we can turn it into a multiplication question by flipping the second part. So we're going to times it by 3 over 8. And then we're just going to multiply through, so 17 times 3 is... What is 17 times 3? 17 times 3 will give you 51 over 16. And what is this as a mixed number? So how many 16s go into 51? That'll be 16, 32, 48. So that'll be 3 and 3 over 16. So that's your answer for this one. Okay, question 6. A ship is sailing in a straight line from its home port. The distance time graph shows 4 hours of the journey. So we've got distance on the y-axis and time on the x-axis. So we've got y and x. Work out the speed of the ship during these 4 hours. Okay, so we know speed equals distance over time. So we need to work out the total distance and the total time. So we start here, and then we're going to go all the way across to here. So that's the distance, isn't it? From there to there. So we know that's the time. So we know the time is going to be 4 hours, and now we need to work out the distance, which is this bit here. So he's gone from, what is that? I can't tell exactly. Let me clear it up. So he's done 48. So he's 48 here, and at the top it is, here is 116. So we need to do 116 minus 48, which will give us 160 minus 48 is going to be 68. So that is the total distance. So total distance is 68 over the total time, which is 4 hours. So we're going to do 68 divided by 4, which is going to give us 17. So 17 miles per hour is the answer. Okay, question 8. Kim works at an airport in the UK. She records the number of planes landing between 10 AM and 2 PM each day. The table shows the date of the first 10 days in January. So we've got day, number of planes. 8A. The airport was affected by fog on one of the days. Which day do you think it was? Give a reason for your answer. Okay, so we want to look at all of these numbers here, the number of planes, and see if there is one which doesn't look right. So when we have a look, we can see they're all about the same, except for this one here, which is much, much lower. So this is day 8, and it says we need to give a reason for your answer. So why is this number different to all the others? So we can say it is much, much smaller than all the other numbers. Okay, 8b. Kim uses the data to predict how many planes will land at the airport in a year. In her method, she uses an estimate of 150 planes in each 4-hour period throughout the day, and she assumes the same number of planes every day. Okay, work out her prediction. So we've got a 4-hour period throughout the day. So how many of these 4-hour periods are there going to be? So there's 24 hours in a day, and we're going to divide it by 4 to get how many periods. So that's going to give us 6. And there's 150 planes in each of those periods. So each day there's going to be 150 planes times 6, which is going to give us 900. Okay, so how many days in a year? So days in a year is 365. So now what we need to do is 900 times 365. Okay, we can do this in many different methods, but I'm going to break it up using the box method. So we're going to do 900 times by 365, so we just split it up into the hundreds, so we can get 300, and then we're going to get 60, then we're going to get 5. So what's 900 times 300, or what is 9 times 3? 9 times 3 is 27, and then we're going to add the zeros back on. And then what's 900 times 60? That's 9 times 6, which is 54, and then you've got to add the zeros. So you're going to get 54,000, and then 9 times 5 is 45, and you've got to add the zeros back on. Alright, now we just need to add these together. So 270,000 I should say, plus 54,000 plus 4,500. Apologies, this isn't very neat. So what are we going to get? So we're going to get 0 here, 0 here. The next column we've got 5, and then we've got 8. Then we've got, what have we got there? A 12, and then we're going to carry the 1. So we're going to get 328,500. So that's everything for 8b. So 3 marks, hardest thing there is just multiplying. Okay, easy peasy. Okay, 8c. In fact, fewer planes land in winter than in summer, fewer planes land at night than during the day. Okay, so the important thing to notice about this question is, when is she recording the data? So she records the number of planes landing between 10 AM and 2 PM, so that's the middle of the day, and it's the first 10 days in January, which is in the winter. So what does this tell you about Kim's prediction? So the answer is going to be, her prediction could be too high or too low, and we need to give a reason. Okay, so let's think about this. So her prediction is about the number of planes during the middle of the day, which will be the most popular time. But we know fewer planes land at night than during the day. So this will mean her prediction will be too high. And then she's taken the data in January. But this is the least popular time for her flying. So that means in the summer there will be more planes. So that will mean her prediction is too low. Okay, so how can we write this? What can we say? So we can write fewer planes landing in the winter will make it too low, and then fewer landing at night will make it too high. Okay, that's it for question 8. Okay, question 9. So this is for 4 marks, so we know there's going to be lots to do here. Okay, work out the value of a. So let's see what we can do. Alright, let's multiply out these squares here. So we're going to get square root of 6 squared, which is 36, plus 8 squared, which is 64, equals, what can we do on the other side? We've got a cube root, and we've got a cubed. So that means we can take the cube root of 125 and the cube root of a cubed, which is going to give us 5a. Okay, so the square root of this is going to simplify to square root of 100 equals 5a. This equals 10 equals 5a. 10 over 5 equals a. And that implies that a equals 2. A equals 2. Done. Okay, so let's see how we got from this step to this step, because that's the tricky bit here. So let's write it out. So we've got a cube root of 125 times a cubed. So how can we split this up to make this easier? So we can distribute the cube root over the 125a to the 3. So what we can do here is we can write it like this. 125 goes there, and then we can have another cube root of a to the 3. And then that's going to go to 25, and then the cube root will cancel with the cube, so you just can get 5a. Okay, I hope that makes sense. It's a bit complicated, but that's it for question 9. Okay, question 10. Work out the percentage increase from 80 to 280. So, from here to here, what's the percentage increase? So, 80... Okay, let's double 80, because we know that will be a 100% increase. Okay, so 100% increase from 80 to doubling it would be 160. Okay, so let's add another 80 to it, because we know that will be another 100% increase, won't it? So that will give us 240. And now we want to get to 280. So what do we need to put here? So each time we're adding 80, aren't we? But this time we want to add 40. So what do we need to add in terms of a percentage? So what's the relationship between 80 and 40? So it's half, isn't it? So we know the jump is going to be half. So this bit is going to be 50%. Now we're going to add our percentages. So 100 plus 100 plus 50 equals 250. And that's our percentage increase. Okay, that was a bit of a weird method for question 10. So how can we do that using a nicer method? Because that's quite intuitive, but you wouldn't always get the marks for that, even though the answer is right. So what we're supposed to do is 280 minus 80, and that's going to give you 200. And then we're going to do 200 divided by 80. And what's that going to give us? That's going to give us 2.5. And now we need to multiply this by 100, which is going to give us 250. Okay, question 11. Here are 4 triangles. Which 2 triangles are congruent? Okay, congruent just means the same. Okay, so which one of these triangles are the same? So you've got to imagine you can rotate them, you can expand them, contract them. So which ones are the same? Okay, there's no easy way to do this. You've just got to look at them, and you can see that A and D are exactly the same. Okay, question 12. Solve x squared minus x minus 12 equals 0 for 3 marks. So we're going to factorize, because that's the easiest way to solve a quadratic. So we want to find 2 things that times together to give us 12, and 2 things that add together to give us minus 1, because we've got minus 1x. So what can we think? What times this together to give us 12? So it's going to be x in this bracket, x in this bracket. So what do we need? We can have, so let's think of the factors of minus 12. So what can we split minus 12 into? Well, we can split it into 12 and 1. That's not very helpful. What about 6 and 2? Still not very helpful. But we've also got 3 and 4. Okay, so it splits into 3 and 4. But we need to have a minus somewhere, don't we? So where can we put this minus? So we want to get them to add together to equal -1. So we're going to take -4 plus 3 equals 0. So to check that, we can multiply it out just to make sure we're correct. So x minus 4 times x plus 3 is going to give us x squared plus 3x minus 4x minus 12. Simplifies to x squared minus x minus 12. Okay, so we've proved that we've factorized it correctly. Okay, so we want to make this side equal to 0 or this side equal to 0. So let's set it up. So we can do x minus 4 equals 0 or x plus 3 equals 0. So this, what does the first one imply? So if x minus 4 equals 0, that means x is going to be 4. And then if x plus 3 equals 0, then we know x is going to be minus 3. So that's our two answers. X equals 4 or x equals minus 3. Okay, question 13. So EF equals 2, 3 and FG equals 5, 4. Work out EG. Okay, so these are ratios. So how can we work this out? All right, let's rewrite it. So EF equals 2, 3 and FG equals 5, 4. So what's the same in both of them? So we've got an F on both sides. So if we get F to be the same, we can get rid of it. So we want to try to get 3 and 5 to be the same. So we can use factors or multiples here to work it out. So we're going to do 3 times 5 equals 15. Okay, so 15 is our special number. We want to make both of them equal to 15. So what we're going to do is we're going to multiply this whole side here by what? Because we want to turn this 3 into a 15. So we're going to multiply this whole thing by 5. Okay, so times this by 5. So we're going to get e to the f equals, so we've got to do both sides times 5, so we're going to get 10 to the 15. And then on the other side, we want to turn this 5 here into a 15. So what are we going to multiply it by? We're going to multiply it by 3. So FG is going to equal 15 to the 12. Okay, so now we've got both of them the same, so we've got 15 on both sides. So now we can cancel them out. So we can say e to the g is equal to what? So this is e and this is g. So we can say e to the g is equal to 10 to the 12. But we want to give our answer in the simplest form. So can we simplify EG? So we could divide the whole thing by, what could we divide it by? Can we divide it by, we can divide it by 3. No, we can't. We can divide it by 2. So if we divide both sides by 2, we're going to get EG equals 5 to the 6. And that's as simple as it gets. Okay, that's it for question 13. Okay, question 14. Probability. A and B are two events and probabilities are shown on the Venn diagram. So we know all probabilities add up to 1. So what have we got? We've got 0.3 plus 0.15 plus 0.35. So what are we missing here? What is going to be the probability for the rest of the diagram, which isn't given? So if the probabilities all add up to 1, what are we missing? So we need to find the remaining one. So that's going to be 0.2. So you can see that by adding them together and finding this missing question mark. Okay, so the probability of not A union B. So let's recall what union and intersection mean. So the union is going to be, the union is all off the diagram, okay, and the intersection is just the bit where they cross. So we want to find the probability of not A and B, not A and B. So what is the probability of not A? So not A is going to be all of this area here, all of this bit on the outside, and B is just this bit here. So we're going to add them, so we can get 0.15 plus 0.35 plus 0.2 equals 0.7. And that's your answer. Done. Okay, question 15. In a survey, queuing times in a supermarket checkouts were recorded. One morning, samples of 50 customers were taken at supermarkets A, B, C, and D. And the box plots represent this data. So, queuing times of A, B, C, D. It says, on average, which supermarket had the lowest queuing times? Give a reason for your answer. Okay, so the lowest ones, we're going to use the median. So the median is the line in the middle of your box plot. Okay, so which one has the lowest median? So it's going to be this one here, isn't it? So that's going to be supermarket C, and your reason is because the median is the lowest. Okay, 15b. At which supermarket were the queuing times the most consistent? Give a reason for your answer. Okay, the most consistent means it has the smallest amount of spread between the lower quartile and the upper quartile. So we want to find the box plot with the smallest distance between this point and this point. So the lower quartile and the upper quartile. So which one is the smallest? We're going to go with B. So supermarket B, because it has the smallest interquartile range. Okay, smallest interquartile range. Okay, 16. Circle the number that is closest to the value of 29 to the power of 3. Okay, closest in value. So what we're going to do is we're going to change this 29 to a 30. So we're going to do 30 to the power of 3. So how can we do that? It's going to be 30 times 30 times 30. So 30 times 30 is 900. 900 times 30 is 27,000, which is this one. Okay, work out the exact value of 3 over 4 to the minus 3. Okay, this one's a bit interesting. So it's a minus 3 here. So how can we get rid of that minus? So what we're going to do is we're going to put it over a fraction, which means we can change it to a positive value. So now we're going to bring our power of 3 out. So we've got 1 over 3 to the 3 over 4 to the 3. Apologies for how ugly that looks. So 1 over 3 to the 3. So that would be 9 over 12. Whoops, no. 4 to the 3. It's 4 times 4 times 4. Wait, no, I've made a terrible error there, haven't I? Okay, 3 to the power of 3. 3 times 3 times 3 is 27. Over 4 to the 3, which is 64. Okay, so now you're doing 1 divided by 27 over 64, which means you can flip them. So you're going to get 64 over 27. And that's your answer. Okay, question 18. Beth and Mia translate documents from Spanish into English. A set of documents that would take Beth 8 days would take Mia 10 days. Beth starts to translate the documents. After 2 days, Beth and Mia both work on translating the documents. How many more days will it take to complete the work? You must show your working. Okay, this is tricky, so we need to be careful here. So we've got Beth and we've got Mia. So let's look at Beth first. So it takes her 8 days to complete it. So let's think of how much of the work she can do in 1 day. So in 1 day, Beth can do how much of the work? So she can do the whole thing in 8 days, right? So in 1 day, she can do 1/8 of the work. Okay, so in 1 day, Beth can do 1/8 of the work. Okay, so let's think about Mia. Okay, so in 1 day, how much of the work can Mia do? So the whole thing would take her 10 days. So in 1 day, she can do 1/10 of the work. Okay, so Beth starts to translate the documents, and after 2 days, they both work. So Beth works for 2 days. So we've got 2 days of Beth's work. So Beth works for 2 days. So how much of the work does she complete in 2 days? So we know in 1 day she can complete 1/8 of the work. So in 2 days she can complete 2/8 of the work. Okay, so that's the work which has been done so far. Okay, so we can write 2/8 completed. And at this point, they both start working together. So Beth and Mia working together, how much do they complete in a day? Okay, so each day Beth does 1/8 and Mia does 1/10. So together they're going to do 1/8 plus 1/10. Okay, so 1/8 plus 1/10 is what they do together. Okay, so to add these you need to do some mixed fractions, don't we? So let's get them both over a common factor, which is going to be 40. So we're going to get 5 over 40 plus 4 over 40 equals 9 over 40. Okay, so this is what they do in 1 day together. So on day 3, let's write this out. So on day 3, they will have done 2/8, because that's what Beth did on her own, plus the 9/40. So what are we going to get for this? We're going to put the first one over 40, so we're going to get 10 over 40 plus 9 over 40 equals 19 over 40. So that's how much they've done on day 3. Now we can just continue this process. So day 4 is going to be what they've already done, which is 19 over 40 plus 9 over 40 equals 28 over 40. Next one, day 5 equals 28 over 40 plus 9 over 40 equals 35 over 40. And then day 6 is going to equal 35 over 40 plus 9 over 40 equals 44 over 40. Okay, now let's look at this number. This number is bigger than 1. So it's bigger than 1, which means they've completed all of their work. So we want to show how many more days will it take to complete the work. So let's see. We started on day 2. So we go from day 2 to day 3 to day 4 to day 5 to day 6. So that's 4 more days. Okay, 4 more days. So that's a tricky question, which I think deserved more than 4 marks, but such is life. Okay, question 19. In a chess club there are X boys and Y girls. If 5 more boys and 8 more girls join, there will be half as many boys as girls. Okay, so boys are X, girls are Y. So we're going to get 5 more boys. So that means the boys is going to be X plus 5. And 8 more girls. So that's going to be Y plus 8. Okay, so it says there'll be half as many boys as girls. Half as many boys. So if there's half as many boys, we will need to multiply the boys by 2 to get up to the same amount that girls have. So there's half as many boys. So we're going to put a 2 over here. So let's rearrange this to get y as the subject. So we're going to move this 2 over to the other side. No, we're not. We're going to multiply 3 by 2. So we're going to get 2x plus 10 equals y plus 8. We're going to get y equals 2x plus 10 minus 8. So y is equal to 2x plus 2. 19b. If instead 10 more boys and 1 more girl join, there will be the same number of boys and girls. Work out x and y. So 10 more boys. So we're going to get x plus 10 is equal to... Okay, so we've got x plus 10, which is 10 more boys, and then y plus 1, which is the 1 more girl. There would be the same number of boys and girls. Okay, work out x and y. So we've got 2 equations we can use. So let's try to set them up both so they're equal to y. So we're going to rearrange this one to get y equals x plus 9, and then we're going to, because we've got a y here and a y here, we can set them equal to each other. So we can say x plus 9 is equal to 2x plus 2, which will give us, we're going to move this x to the other side, so we're going to get x is equal to 7. Okay, so if x is equal to 7, then we're going to substitute the 7 back into here. So we're going to get y equals 7 plus 9, and then y equals 16. And that is 19b done. Okay, question 20. P, Q, R and S are points on a circle. PXR and QXS are straight lines. And we know PX equals SX. So we want to prove that QS is not a diameter of a circle. So Q to S, we want to show this is not the diameter of a circle. So let's recall our circle theorems. So if it's a diameter of a circle, we know the triangle formed with the edge, we know that this one here is going to be a right angle. So we know this is going to be 90 degrees. So we want to prove that QS is not the diameter of the circle. So we want to prove that QPS, we want to prove that QPS is not equal to 90. Alright, so the easiest way to do this is to just fill in all the angles we know. So we know angles on a straight line like this, these will add up to 180 degrees. So we can apply that here. So 180 minus 50 is going to be what? 180 minus 50 equals 130. So we can put 130 here, and we can do the same on the other side. So this one's going to be 130. What other angles can we figure out? We can work out this one. So we know they have to equal 180, don't we? So 180 minus 130 plus 27. So that is going to equal what? 157, so we need an extra 23 on there. So that's going to equal 23. What else can we do? Let's see. What else do we know? Okay, we also know PRS is going to be equal to PQS. So we can put this angle is going to be equal to 23 degrees. And then this one is going to be equal to 27. Okay, so we've got lots and lots of angles filled in now. We just need to find the last few. Alright, so let's take a look. We know that px and xs are the same. Okay, so we know this is going to form an isosceles triangle with an angle of 50 degrees. Okay, so we know this one is 50, and then we also know these two here, these two are going to be the same. So we're going to have to find out what they are. So we're going to do 180 minus 50 equals 130. And now both of these angles added together is 130. So we're going to do 130 over 2 equals 65. So we know this one is 65. We know this one is 65. So we're going to do 27 plus 65, and that is going to be 92. So 92 is our angle we were looking for, which is QPS. So QPS equals 92, which means that QS is not the, what are we proving? Not the diameter of a circle. Okay, question 21. We have a quadratic sequence. Work out an expression for the nth term. Okay, so let's write the term number above. So that's the first term, second term, third term, fourth term. So for these questions, we're looking for a formula which takes you from this one to this one, which is always quite challenging. Okay, so let's work out the differences between these numbers. So 11 to 26, how do we get there? You've got to add 15. 26 to 45, how do we get there? You've got to add 19. 45 to 68, how do we get there? You've got to add 23. So that's the first difference. So what's the second difference? So the second difference, to get from 15 to 19, you're adding 4. To get from 19 to 23, you're adding 4. So the second difference is 4. So let's write that down. Okay, so with quadratic sequences, we know the formula is going to be un equals an squared plus bn plus c. And we can find these using 3 more equations, where 2a equals the second difference, which we've already found. And what's the second equation? That is 3a plus b equals u2 minus u1. I'll go through what u2 and u1 are in a minute. And the last equation is a plus b plus c equals u1. Okay, so what's u1 and u2? u1 is the first term in the sequence, and then u1 minus u2 is the difference between the first and the second term. Okay, so let's fill in these equations for the question. So 2a is equal to the second difference, and the second difference equals 4, so 2a equals 4. That implies a equals 2. Alright, so the second equation is 3a plus b, oh, whoops, let me put in the numbers, 3a plus b equals u2 minus u1. So u2 is the second term minus the first term. So 26 minus 11 equals 15. So 3a plus b equals 15. But what else do we know? We know a equals 2. So we can know 3 times 2 plus b equals 15. So we know b equals 9. Okay, last one. A plus b plus c equals u1. So we know a equals 2. So 2 plus b, which is 9. So b is 9. Plus c equals u1. And u1 is the first term, which is 11. Okay, so let's see. So that implies that c is equal to 0. Okay, so we've got a equals 2, b equals 9, and c equals 0. So we want to substitute this back into our original equation. So that's going to give us un is equal to 2n squared plus bn, b is 9, so 9n plus 0. So we can get rid of this 0, and then we are done. Alright, question 22. So we want to solve this equation for x. So the first thing we're going to do is try to get rid of these denominators. So we're going to multiply it through by x plus 4 and x minus 2. So what we're going to get is x times x minus 2 plus 7 times x plus 4 equals 1 times x plus 4 times by x minus 2. Okay, so let's simplify every single line. So we're going to get x squared minus 2x plus 7x, 7, 14, 28 plus 28 equals x squared minus 2x plus 4x minus 8. Okay, so let's simplify both sides. Okay, so we've got x squared plus 5x, put these ones together, plus 28 equals x squared, do these two together, plus 2x minus 8. Let's have a look. X squareds cancel on both sides. Let's move the x's to the same side, so we're going to get 3x equals, okay, so we need to move the 28 to this side. So we're going to get minus 8 minus 28. Is that right? Minus 8 minus 28 is going to give us minus 36. So x is going to equal 12, minus 12. So x equals minus 12. Done. Okay, question 23. Prisms A and B are similar. The cross sections are shaded. Prism A has a volume of 480 centimeters cubed. Prism B has a length of 30 centimeters cubed. So we have a ratio of the area of the cross section of A and the cross section of B, which is 4 to 9. So we know this area is 4. Well, we don't know the area is 4. We know the ratio of the areas of 4 and 9. So if this one was 4, this one would be 9. But those aren't the actual areas. Those are ratios to the areas, so we need to be careful. So work out the area of the cross section of B. So we want to find out this area here. Okay, it's not 9. That's the ratio of the area. Okay, so we know the ratio of the area, so let's put that down. So the area is 4 to 9. Now if we use the area being 4 to 9, we know the lengths will have a similar ratio. But because areas are 2 dimensions and lengths are 1 dimensions, we need to take the square root. So we're going to take the square root of 4 and the square root of 9, which is going to give us 2 to 3. And now we can use this ratio here to work out the length of prism A. So we know 30 centimeters will imply the length of prism A is going to be 20 centimeters. So we know that this is going to be 20. So now we can work out this area here. So we're going to do 480 divided by 20, and that will give us the area. So that's going to give us 24. Yeah, okay. So we've got 24 is the area of A. So this area here is 24. But we know the ratios are 4 to 9. So we need to do 24 divided by 4 times 9. So what we're going to get, 24 divided by 4 is 6. So we're going to do 6 times 9 is 54. So the answer here is 54 centimeters squared. Okay, question 24. Show that 2 root 6 over root 5 minus root 3 over root 10 can be written in the form c root d over 10, where c and d are integers. So what we want to do here is get the bottom two denominators to be the same. So what can we do to root 5 to make it root 10? What we can do is, we know root 5 times root 2 equals root 10. So we're going to times this one, the top and the bottom, by root 2. So what we're going to get is 2 root 6 times root 2 over root 10. Okay? And now we can bring in the other bit. Minus root 3 over root 10. And now we can put the whole thing over one denominator. So we've got root 10 at the bottom, and then we've got 2 root 6 times root 2 minus root 3. So we can put this root 6 and this root 2 together. So we can get 2 root 12 all over root 10 minus root 3. And what can we do to this root 12? What can we do to that? So we can get 2, we can split it up. We can split it into root 4 and root 3. Minus root 3 over root 10. And what is root 4? What is root 4? So square root of 4 equals 2. So that's another line we can simplify. So we can get 2 times root 3 minus root 3 over root 10. And we're getting somewhere now. So 2 times 2 is 4. So we've got 4 root 3 minus root 3 over root 10. So 4 lots of root 3 minus root 3 equals 3 root 3 over root 10. And now we just want to get the bottom to be 10 instead of root 10. So what can we do now? We can times the whole thing by root 10. So we're going to get 3 root 3 times by root 10 over root 10 times by root 10, which is going to give us, the bottom is going to be 10, which is what we want, and then the top is going to be root 3 times root 10 equals root 30. And I think we're done. So the bottom is root 10, sorry, the bottom is 10, which is what we wanted, and then we've got c root d, so c equals 3, d equals 30. And we are finished. Alright, so question 25. A quadratic curve intersects the axes at -3, 0, 3, 0, and 0, 18. Work out the equation of the curve. Okay, so let's write the general form of a quadratic, which is y equals ax squared plus bx plus c. Okay, so let's look at the 3 points we have. So let's start with the easiest one, which is 0, 18. So at 0, 18, this equation is going to be what? So we know x is 0, y equals 18. So we're going to get 18 equals, well, the x terms are going to disappear, and we're going to get 18 equals c. Okay? Alright, so now let's try a different point. Let's try at 3, 0. So at 3, 0, we know y is 0. So we know y is 0. We don't know a. We do know x. So what is x? So x is 3. So that's 3 squared plus b. We don't know b, but we know x. And we do know C. C is 18 because we worked out before. So plus 18. And then finally, let's do at this last point here. So we're going to have at minus 3, 0. What's our equation going to be? So we know y is 0. We don't know a. We do know x, which is minus 3. We do not know b, but we know x is minus 3, and we know c is 18. Okay, so let's neaten up these equations. So this one is going to go to 9a plus 3b equals minus 18. Okay, that looks good. And this one is going to go to 9a minus 3b equals minus 18. Okay, that looks nice. So let's get them both equal to 9a. Let's set them both equal to 9a. So we're going to end up with two equations. So equation 1 is going to be the first one. It's going to be 9a equals minus 18 minus 3b. And the second one is going to be 9a equals minus 18 plus 3b. So now we can set them equal to each other because they've both got a 9a term. So we're going to get minus 18 equals minus 3b. Oh, whoops, sorry, mistake. Minus 18 minus 3b is equal to minus 18 plus 3b. So let's add these b's together, or let's simplify both sides. So we're going to get 6b is equal to 0. So b equals 0. Okay, if b is 0, can we work out a? So let's take our 0 and put it into the original equation. We can use any of them. So let's use the second one. So at 3, 0, we know y is 0, and we still don't know a. That's what we're trying to find, but we do know x. X is 3 at this point, so we can get 3 squared plus, well, b is 0, so this term will disappear, plus c, which is 18. Okay, so now we can work out a. So we know 0 equals 9a plus 18, which means minus 18 equals 9a, so a equals minus 2. Okay, so we're done. So we know a equals minus 2, b equals 0, c equals 18. So we can substitute these into this. So we're going to get y equals minus 2x squared, no b term because b equals 0, plus 18. And that's the final answer. Okay, 26. The area of this triangle is 25 root 3 centimeters squared. And we're given a side and an angle and an area. Work out the value of w, give your answer in form a root b, where a and b are integers greater than 1. Okay, so first things first, let's recall the area of a triangle formula. So we know area is equal to half AB sine C. So let's label this diagram. So the big angle C, let's call this one A, let's call this one B. And then the sides are always little letters, so C, A, B. Okay, so let's substitute in what we know. The area is 25 root 3, so we can put that in, is equal to half AB, where we know A is 20, we don't know B, so we're just going to call it X. Well, we can just keep it B, that makes life a bit easier. sine c, and c is 60 degrees. So we know from the special angles on our triangle that sine of 60 equals root 3 over 2. Okay, so let's simplify this to find out b. So 25 root 3 is equal to half of 20, so let's call that 10. 10b root 3 over 2. Simplify that, we're going to get 25 times 2, because we're going to bring this 2 up. So 25 times 2. What have I missed? I've missed the root 3, haven't I? 25 root 3 times by 2 all over 10 root 3, and that's equal to b. So what are we going to get here? We're going to get 50 root 3 over 10 root 3 equals b. So the root 3's will cancel. 50 divided by 10 is 5. Okay, so 5 equals b. b equals 5. So let's put that on. So we know this one, b is equal to 5. Okay, so now we want to find this last remaining side. And we have 2 sides and 1 angle. So that means we need to use the cosine rule. So we know that c squared, because c is the side we want to find, is equal to a squared plus b squared minus a b cos c, because of big C. So now we can substitute some numbers in. So we don't know c because that's what we're trying to find, so c squared we're going to leave, a squared, so that's going to be 20 squared plus b squared, which is 5 squared, minus 20 times 5 times by cos c, cos of c, and we know c is 60. So cos of 60 we know is 1/2. So let's rewrite and simplify this line. So c squared is equal to 400 plus 25 minus 100 cos 60. And cos 60 is 1/2. Okay, let's recheck this formula because I've made a mistake. So c squared equals a squared plus b squared minus 2ab cos c. So we've missed out 2 here. So it's not 100 times 1/2, is it? It's going to be 200 times 1/2. Okay, good, we found the mistake. So c squared equals 425 minus 100 equals 325. So that means c is equal to the square root of 325. We can split this root into 2 roots, can't we? So we can do 25 and 13. So c is equal to 5 root 13, which is our answer. Okay, last question. 27. Here is a sketch of y equals cos x for the values from 0 to 360 degrees, where a is an acute angle and cos of a equals x. Okay, circle the value of cos 180 minus a. Okay, so this is a, your value of a. Okay, so we're going to do 180, which is here, minus a. And what is our value down here going to be? So if this is k, this is going to be negative k, isn't it? Okay, so you can just see that from the picture. Okay, 27b. Circle the value of cos 360 plus a. So cos, what can you tell me about cos? So it goes up and down, up and down, up and down, and it just repeats the same thing every 360 degrees. So that tells you that it's going to be exactly the same because it's a cyclic function. Okay, so for this one, the answer is just k.